All right, ladies and gentlemen, let's hope that this works here. Um, it's been a hard time trying to do this, but let's go ahead and see. So, to be able to solve problems like x squared is equal to -4, mathematicians created an expanded number system that uses the imaginary unit I. Imaginary unit's a kind of a bad word. They don't really, that's what they called it at the beginning, and it just stuck. But with the imaginary unit I is equal to the square root of -1, and I squared would equal -1. So find the square root of each number, for example, 1. So again, if I can get a square root of -1 out, then I can go ahead and make an I. So I do have the square root of 81. I do have -1. So the square root of 81 is 9. And -1 we just said was I. For the second one here, we can write this as the square root of 56 times the square root of -1. Now let's go off to the side here, because we can say that 56 is 2 and 28. And we know that 28 is 2 and 14. And 14 we would know is 2 times 7. So now, since we're talking about square roots, remember, if I have two of them that are the same, I can pull that out. So in this case, we do have that. So I can write 2 times, again, I'm going to bring those two back together. So 2 times 4 is 14. And then that'll go back under the square root. So the convention is I'm going to put the square root in between the whole number and the square root. So the I will go between the whole number and the square root. And then on the last one there, we can also simplify that. We'll have 7I. Remember, square root of 12 we can write as 4 times 3. And so then on that one there, we know that square root of 4 is 2. So 2 times 7 is 14. So on this one here, I'll get 14I root 3. So a complex number is any number that can be written in the form a plus bi, where a and bi are real numbers, and I is the imaginary part. So in that case there, a and b are still real numbers, but a is the real part and b is the imaginary part. So two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. So example 2, find the values of x and y that satisfy the equation 5x minus 20i is equal to 35 plus yi. So again, we were just told that the a parts equal the a parts, and the I parts equal the I parts. So 20i is equal to yi. And if we solve those, we'll get that x is equal to 7, and we'll get that y is equal to -20. All right, so to add and subtract complex numbers, combine the real parts and combine the imaginary parts. So when we add, we're going to take our real parts. So our real parts on both of these are 2 and 11. We're going to take our imaginary parts, which are 9i minus I, and that will give us 2 plus 11. And I'm probably adding an extra step than I need to, 9 minus 1i. And if we do that, 2 plus 11 is 13, and 9 minus 1 is 8, and that'll give me the I. Same thing here. I'll have 13 plus 4i. Remember, I'm distributing that negative through the parentheses, so I'll have minus 8 minus 4i. Now combine the imaginary parts. So I'll have 13 minus 8 plus 4 minus 4 pi. Well, 4 minus 4 is 0. 0 times anything is 0. So on that one, we're going to just get the whole number, 5. And then sometimes I like to move it around here. So on this one here, I can write this as 16 minus 13 minus 6i plus 8i. All right. 16 minus 13 is 3. Negative 6 plus 8i is equal to 2i. Okay. So to multiply two complex numbers, use the distributive property or the FOIL method or the generic rectangle. I kind of put the generic rectangle there on that last problem from yesterday. Of course, I didn't have the video. I might get to it today. I don't think so because my family wants me to quit doing schoolwork. So on this one right here, I have 15i by itself, but it's being multiplied to everything in the parentheses. So remember, on this here, we're going to say use the distributive property. All right. So if I do that, I'll get negative 15i plus 15 times 2 is 30. And then I'll have I squared. But remember what I just told you up above? I squared is equal to negative 1. So on this one here, I'll have minus 15i plus 30 times negative 1. And again, we want to put it in a plus bi form. So on this here, I'll have negative 30 minus 15i. All right, the next one we're going to FOIL. So remember, FOIL means first, outside, inside, last. So if I take the first terms, I'll have 4 times 11. I'll take the outside terms. That will give me 4 times 8i. So that would be plus 32i. I'll take the inside terms, which are minus 12 times 8i, which will give us a 96. Let's see, 12i times 11 is 132. Remember, that is an I times an I, right? No, wait, 12 times 11 is not, sorry. And let's see here. And I'll have 12i times 8i. Well, it's negative, so that'll give me negative 96 I squared. But again, I just told you I squared is equal to negative 1. So I can simplify this to 44 minus 100i plus 96. Again, put everything together. That'll give us 140 minus 100i. Let's see. Now, when we have x squared plus 121, our last ones we're going to solve. All right. So on these ones here now, we can write that as x squared is equal to negative 121. We can now still remember to undo a square, we square root it. We're in algebra 2 now, so we're going to put the plus and minus in front of it. And that will give me negative 121. And remember, I can now write that as plus or minus 11. And I have that negative under the radical sign. So that would just be I. Second one, we have 3x squared plus 25 is equal to 416. I'm going to take 3x squared. If I subtract 25 from 416, that'll be negative 441. I'm going to divide through by, let's see, x squared. I'm going to divide by 3. That'll give me negative 147. So x will equal the square root of 147i. And let's see here, what can we do with 147? I didn't write it down, so I'm going to have to do a factor tree again. So I'm going to do 147. Well, let's see, that would be 7 times 21, wouldn't it? And 21 would be 7 times 3, or 3 times 7. There's my matching pair. So I can write this one here then as 7, right? I root 3. And then finally the last problem. Okay, find the zeros of f of x is equal to 7x squared plus 70. We're going to set f of x is equal to 0. So I'll get 7x squared plus 70 is equal to 0. Now I can say 7x squared is equal to negative 70. X squared is equal to negative 10. So I'll get x is equal to plus or minus the square root of negative 10. Now that plus or minus will still be there, even though I have an I there, right? I still have the plus or minus. And again, the only thing that'll come out is the I, and then I'll have root 10. All right, ladies and gentlemen, cross your fingers. Hope this one works.